Hi everyone, today we'll be starting in on desktop applications. I've chosen to start with the traditional desktop application because they're really the beginning of everything. You've been using desktop applications or computer programs for a long time now.
When you open up Microsoft Word or your web browser, those are all programs. Of course, you don't have to know how to write programs yourself anymore. There are a lot of sites like Upwork where you can hire a developer, or a coder as they're sometimes called, to do the programming for you. But if you want to manage your developer effectively, it's still important to understand the overall process of creating a program. Let's start from the beginning. Let's say you want your developer to create a simple program that opens up a window and prints "Hello World." Making the program starts with your developer writing computer code. Just like you have Microsoft Word to write and edit your documents, a developer has software they use to write and edit code. Code can be written in a lot of different computer languages. Each language has its uses. No one developer can be good at every language or do everything, so they tend to specialize in certain areas. That's why when you're looking for your developer, you'll want to make sure his skills match your plans. Here's an example of some code. You do not need to understand it. I've just included it to show you what computer code looks like. For the record, this code is written in a language called Visual Basic, and all it does is print a line of text on the screen that says "Hello World." After they've written their code, the developer uses a special program called a compiler. A compiler is a complicated thing, but when you get right down to it, what it does is pretty simple. You give it code, and it turns it into a program file that a computer can run. That's all a computer program is, really. It's a file created by a compiler that contains instructions that tell the computer what to do. There are some variations on this process, but that isn't really something you'll need to worry about. Remember, you don't need to compile or code anything yourself. Your software developer can and should do all that for you. So what happens when you actually run the program we just created? When you click on that program icon, Windows, or whatever your operating system is, realizes that you're trying to open the file. It can tell that it's a program file, so it opens the file, reads the instructions in it, translates those instructions, and passes them along to the computer. In our case, it tells the computer to open a new window and print "Hello World" on it. Well, that's not very impressive. With all the work we put into this thing, you'd think it would do more than say "Hello World." But the basic process is the same, whether you're making "Hello World" or the next big thing. There are a few implications here that it's important to bear in mind. First, as I said, your program uses the operating system to talk to the computer. That's why a program for Windows often won't work on a Mac. Your program was compiled to be understood by Windows, and your Mac can't understand it. It's like taking a vacation to France and trying to talk to them in German. That's why you see so many more programs available for Windows than other operating systems. It requires extra time and money to make a program work for more than one operating system, so a lot of companies just develop for Windows since the majority of desktop PCs run it. There are a few exceptions to this one OS limitation. For example, Java programs can run on a lot of different operating systems. Bear in mind that many programs work by interacting with other files on your computer. For example, when you use Microsoft Word, it opens and saves Word docs that are on your PC. Or when you play Minesweeper, the program has files that come with it that have the drawings of the mines and the flags and things. Then when you get a high score, the program writes it down in another file so that it can remember what your score was. There are a couple of key types of files that you're likely to run into. Let's go over them so that you know what they mean if you hear about them. Number one is config files. A lot of modern programs have them. A config file is just somewhere where the program can save and load information about the user's settings. Usually it's for storing simple stuff like recent file locations or whether the user likes to run a program maximized during a window, that kind of thing. You'll also hear people talk about databases. The idea behind a database is actually pretty simple. It's a way for a computer to store information so that it's easily searchable. You'll run into databases a lot, so let me give you a short example of how they work. Let's say you're making a program that stores information about your DVD collection. Your program should be able to store which movies you own, and information about each movie, like the genre and what the movie is about. A database would let you store all this in an organized way. Databases store information in spreadsheets that we call tables. In our example, the database would have a table called Movies. Our table would have columns in it, for the movie name, the genre, and the description. When we add a movie to our collection, our program would add a new record to our table. One reason why databases are used so often is their ability to search. For example, let's say you want to be able to search for a horror movie that takes place in Japan. Your program can access the database and get all the movies where the genre is horror and the word Japan is part of the description. A developer can ask the database for these entries using a database language called SQL, or SQL as people usually call it. As you can see, a database can be a powerful way of organizing information. Common small desktop databases include Microsoft Access, and larger, more full-featured databases for larger desktop programs and for web applications include MySQL, Microsoft SQL Server, and Oracle. By the way, just a tip, only use Access if your program doesn't have a lot of users trying to connect to the database at the same time. Using Access for larger applications or for websites can cause problems, since it's really designed for smaller stuff. Now let's talk for a minute about programs themselves in a little more detail. I'm going to show you something that can save you a lot of time and money. We've talked about how developers write code to make programs, but do they really write everything themselves? The answer is usually no. For example, take a look at this pop-up window. If you've got Windows, you've probably seen it a lot. It's the thing that pops up whenever you want to save your file in Word or Photoshop or dozens of other programs. Now ask yourself, is every developer writing their own code for this pop-up window? Definitely not. Developers use pre-made pieces of code called libraries in their programs so that they don't have to reinvent the wheel every time they're doing something common. It's like building a house. If you need lumber, you don't cut down trees and saw your own boards. You go to Home Depot and pick up what you need. Some of these libraries, like the one that lets you use the save window, are just included with the tools your developer uses. Others are available on the internet. Some are free, some you have to pay for. By the way, it isn't just desktop programs that have libraries. There are libraries for web and mobile apps as well. Now, why should you care about this? After all, you're not the one who has to do the programming, right? Actually, you should care about this kind of thing. Here's an example that will show you why. It's based on a real development situation I ran into. Let's say you're in charge of making a program that has to open and edit Adobe PDF files. You have two choices. Have your developer write code to work with the PDF files, or buy a library for him to use that costs $100. At first, the answer seems obvious, right? You have the developer code it himself and save $100. But wait a minute, you're paying your developer by the hour. Let's say that your coder is charging you $10 an hour. Let's also say that it'll take them 30 hours to do it themselves. That means you'll be paying them a total of $300. Now let's take a look back at that library. Even if it takes your developer 5 hours to set up the library, you're spending only $150. That's half of what you would have spent to do it yourself. You get it done faster too, since your developer only took 5 hours instead of 30. The moral of the story is that if you're planning on doing something that it seems like everyone else is probably doing, ask your developer what your options are for libraries and get their advice. Most developers like to save time and effort, so they're open to ideas. However, they're often reluctant to ask you to pay for a library. So if there's something that seems to be a challenge on your project, have a conversation about your options. We'll talk more about libraries in our web development section, by the way, so stay tuned. Incidentally, you may also hear libraries referred to as SDKs or toolkits, but it basically all means the same thing.
This marks the end of the first desktop lecture. By now you should have a good idea of how a program is made. Next time I'll be building on that foundation and showing you how to design, manage, and test your software projects. Till next time, thanks everyone.